This paper was presented at the JCT Traffic Signal Symposium 2025. Video coverage of this paper is provided by Highways News and sponsored by Mobius Networks, AGD, Smart Micro UK, TRL Software, Traffic Group Signals, AD Electronics, and 4-Way Consulting.
It's great to be back at JCT. Having presented for a couple of years on Fusion, and today, looking to present some case studies with our latest and greatest adaptive control system, which is Fusion. So where else would you want to be on a Wednesday morning, right? Ready to talk about some real-world deployments on traffic signals. So I'm going to take you through those three case studies. We're going to look at one from London, one from some of our early rollouts looking towards Tees Valley, and then we'll look at the sort of results of some of the changes we had to make. So you'll sort of see some of the real positive things, and you'll see some of the challenges that we faced as well. And I think it's always good to sort of present these here and give you guys a feeling of how our journey has been rolling out Fusion. So where are we as such? So the Fusion early adopters program sort of has started. And throughout 2025, we've had deployments in the UK, mainland Europe, Middle East, and North America. Yes, I put the continents there because it sounds more exciting and more interesting. But it's been a good year where we've had lots of feedback. We've had about 250 junctions configured and validated during that time. And we've had our consultancy services team very much supporting that early phase rollout, making sure we're sort of getting the most out of the new system, helping with those lessons learned, and doing the best practice as such. We do all our work with Fusion in partnership with Transport for London. They're our co-partner, and they're also helping to build up the case studies and the best practice guidance for us throughout this. Cool. Everywhere I go, I get asked, how is Fusion doing in London? So I thought I'd just put it front and center at the very start, just give an idea of the feeling, and I'll do the first case study based on London ultimately. So to say, they are our active partners in developing Fusion with us and sort of steering the features and giving good feedback. And this map was kindly provided by them. So their rollout, they're at around 100 sites configured with Fusion at the moment. That's the ones in blue. And their plans are nice and ambitious, which is good to see, and sort of looking to roll out up to sort of 500 sites by about April next year. So that's quite an accelerated program that they're going through at the moment to really get Fusion installed and running. So yeah, there's been quite a lot of good progress within London over the last sort of 12 months. Digging into it a little bit. So I wanted to just give you a bit of a feel for how are they using Fusion. Wanted to showcase Stockwell in London, and just give you an idea of some of the features, and I'll give you some practical examples of what's actually happening there. So I am going to have to go a little bit quick. I've been told we're going to be quite strict on the lights, so I might whistle through this, but obviously do come and see me if you want more questions afterwards, so we'll see how this goes. So we've got Stockwell, sort of busy region near a tube line. We've got 6 junctions and a pedestrian crossing. So ultimately, we've got pedestrians there. There's dedicated cycle lanes. There's buses running through. It's a busy region. And some of the features that kind of want to just pull out, and I'll dig a little bit deeper into the sort of fixed offset one in the next slide. But you'll sort of, I think I've got a pointer. Yes, I do. So in that sort of crossway point, that's where you're sort of, you've got 2 busier roads going through. So that's where they want to make sure they've got some fixed offset and good progression going through. So they're able to make use of the features within Fusion, and I'll show you that in a second. They want to make sure good movements for that sort of north-south, east-west movements. We do have some multimodal sort of optimization going on. There's dedicated cycle lanes, so there's detection with that. So you're getting that input coming into Fusion. You've got differential bus priority as well as general traffic movement. So again, some features being considered. And I always like to shout about phase delays. It's not the most exciting feature to talk about, but at least just making use of phase delays means we can model the link behavior a little bit more accurately and actually show what's actually happening within the controller and be able to get the most out of each of those links. So our modeling is a little bit more improved. But I hear you say, Andy, that's all high level. I want more. Give me some more detail. So we want to see some tangible examples of why fusion is a little bit different. It's not the same as the previous method of control. So who here set up a multi-node before? A few hands. Who enjoys setting up a multi-node? The consultants? Yeah, okay, yeah, understood. Now, so ultimately, this was set up, and we've got these middle junctions where we've got a multi-node configured, and it is a little bit challenging. So hopefully you'll be able to see this as I sort of move through. Yes, I had too much fun on Monday night with animation. You'll see that throughout. But this is our fusion plan. So this is 3 junctions that we want to configure our multi-nodes. And for those with keen eyes, you'll see a little dashed line. This is straight from the Fusion UI. And you'll be able to see this is where the user can configure what a fixed offset looks like. And this is trying to be as simple as possible. So you'll have your 3 different plans for your junctions. You want to define a fixed offset so the user can configure that. And they sort of say, I want it from the start of this stage to the end of the next stage, or whatever way they've set it up. And they're able to configure that. If this was a multi-node, I'm sure I'll get feedback on this afterwards, but I had a bit of fun. If I was to set up the multi-node, where would I put my multi-node stage? Where would the start and end be, considering if this is the plan that you wanted to implement? Well, would I define the multi-node here and group these 3 junctions in that way with the stages in between? Well, there's some compromises with that. You'll have splits running 10 seconds too early, or you'll have, in that middle, in the green bar in the middle, well, that won't have any split in that setup. It won't actually be able to adapt at all because the way it's been drawn. Or if you look at the bottom one of junction 2, again, you'll have this split running a bit too early. Okay, so what other options have I got? Maybe I'll define my multi-node this way. And you start having this coupling effect between junction 1, stage 2, is sort of coupled with junction 3, and the adaptions are very much tied together. So you're making decisions at the first junction that based on the 3rd junction, and that's not necessarily what you want to do. So, in very quick format, just trying to say, by being able to set up these simple associations and fixed offsets and actually just fixing the parts that you want to fix between the stages, you're actually able to get a lot more freedom, a lot more flexibility in the plans that are configured. So you've got free choice for stage 1 at the first junction, and the splits aren't coupled with other junctions the same way. You're only fixing the single parts. So this gives a lot more flexibility to the junction, more adaptation possibilities, and actually it is different to setting up a multi-node. I'm sure people have questions and do come see me afterwards, but I wanted to give something tangible there. And I had to put a few quotes in from TfL. I'll not read them all out. I'll stick with this bottom one. Love that. Obviously, I'm biased. I was genuinely impressed with how well the fixed offsets work compared to the multi-node. And there's a few other bits and pieces there. But again, this was given a tangible benefit to be able to sort of give more flexibility, more adaptions within the junction. But I didn't want to stay on London the whole time. So I wanted to pick on some other areas. And we have learned a lot in sort of rolling out those sort of 250 sites in the last sort of 12 months. So I wanted to show an area that we've had some challenges, and that's been quite interesting. That's where we've learned a lot as well. So I will go through it a little bit quickly because already I can see the time. But again, do catch me afterwards. So we had rolled out a bunch of sites, and all was going well. And we started to get this feedback from the engineers. And again, it's like a gut feel to start with. You're starting to say, I'm not sure this site's running quite the way I want it to. So we've got some examples. This is really looking at the cycle time. So, typically, preaching to the choir as such, you want the cycle time to vary with the demand that you're seeing on street, making sure you're not wasting any green time. And we were seeing lots of that in junctions that we're sort of setting up where the cycle time was varying with demand. We were happy. But the engineers were saying, okay, in some of these sites, actually, I'm not getting the variation I really want. And you were seeing this sort of picture at the bottom right, where the cycle time was sort of flatlining and not varying as much as we'd like it to. So we had to dig into that. And I'll give you a snippet of how we went through that process and then what the outcomes were afterwards. So how did we investigate it? Well, dare I say, some good engineering methodology, isolate the problem as much as possible. We worked with the engineers, went to a simple junction on street where we were seeing the issue, and we very quickly realized actually our forecasts weren't as accurate as we wanted them to be. So I'm not going to go through all the graphs. I'm probably throwing too many into this presentation today, but we'll see how we go. But we realized there was a problem with the forecasting. So we wanted to then say, okay, how do we take this into a nice, safe, offline environment? We can replicate it, we can learn from it. So we've got some cleverness with the dev team, kudos to them. They were able to take the live config, replicate the demand, the scenario, all in a sort of safe environment, be able to then figure out what was really going on behind the scenes. And within hours, next day, we were able to have a proof of concept. And with the proof of concept, again, I'll not go through every bit of it, but you can see if purple was what it was like when we really picked on the problem that we had found, and then very quickly we were able to get some variations. So we were like, okay, we've got something to go on. We went through some ideas. So before we just roll that out and shove it back on street and see what happens, we wanted to stress test. So again, I'll not go into great detail, but basically created our environment. We wanted to test it thoroughly, came up with our scenarios. And for everyone frantically reading that graph on the right-hand side, basically the way it was having more delay, and as the demand was dropping, we were seeing that the cycle time stayed longer than we wanted to in these specific scenarios. And if we did some changes with our proof of concept, we were able to make some change. So we actually changed our optimizer, changed some other levers that we had about the target degree of saturation, and we were able to see some interesting outcomes. So again, that was quite good. Test it in simulation, see the outcome. But again, wanted to just make sure we got some confidence, so we did some controlled testing. Went out on street, back to the site where we had some challenges, and we were able to compare, not but 2 weeks later, to sort of have on the same sort of day of the week and all that, where you have the blue line where it was having consistent cycle time, and we wanted to see some variation. So after a little bit of on-street, and again, shouting out to, it was a bit of a team effort. It wasn't just the traffic engineers, dev team supporting as well, just to make sure that really understanding. And we were able to repeat this sort of process at the next sites. And we went from site to site, learning and making sure we're actually quite happy with it. So you're all saying, that's all well and good, Andy. Great. You've told me you had a problem and you think you fixed it. But I want to take it a little bit further. We're at JCT after all. So we wanted to see how the results actually looked. So then we took our learnings from that sort of the challenges essentially, and we went to one of the regions that we were quite comfortable with. Enter South Stockton Bypass, so region RSS. This was one of the first regions we had done at Tees Valley. It had been happily running 6 months. Engineers were quite happy. We hadn't seen cycle time challenges here. So we were kind of thinking, is this a good place to go and test out the new change? Because we didn't want to destroy something that was working well. Ultimately, making optimizer changes, we need to think about it. And then we had some good available independent data, which is like food and car data essentially from what we call journey time as a service. So we have a site now that we're able to test that we were happy with before any changes made. I'll just take you through some of that as we sort of dug into it. Time is tight, so I don't want to say trust me, but you can come see me afterwards. We used the same process that we did when we presented the Hampshire trial a couple of years back. We made some changes to really focus in on delay. Still the same total journey times, but wanted to target what delay looked like by removing sort of the free flow journey time in a semi-automated way. We wanted to make this process as robust as possible and reproducible. So I guess we're saying we went from journey time into delay was kind of the idea. So what everyone wants to see, right? Let's see some results. So if I just explain the table ever so slightly, down this side, we have 7 journey time links running through that region. You have our different time periods. So for each of the journey time links, you have your morning peak, your evening peak, and your intra-peak or off-peak, whatever way you want to phrase it. So we wanted to do that. We had what we calculated as a free flow journey time, a demand, just to give you some perspective on what that looked like. And then we basically had, okay, so how does the old optimizer, if I can call it that, with the cycle time, what does that journey time look like for the region? So that was the way we approached it. And of course, things are never straightforward. The engineer goes out in the street and was like, oh, actually, I might make a couple of config changes during June. So they made a few config changes. Fine. You were able to see, and I thought I'd throw that out there, that they made some changes, great, they were really happy, and they were seeing some benefits. Green is good, red is not so good, but essentially there was a policy decision of this approach was less important, so we were happy to sort of degrade that performance for the benefit of the region. So that was fine, that was old optimizer, But now, if we look at the new optimizer as such, so again, we wanted to chat to the customer, worked with the engineer, and they were sort of saying, okay, with this new cycle time optimizer, how is the performance impacted across the region? And the customer was happy, the engineer was happy with the behavior, and ultimately we were able to sort of present that to them and sort of kind of run through it. So they're like, okay, I'm happy with this new one, let's see what it looks like. But it doesn't quite stop there. The conversation, unsurprisingly, customer says, well, you've got some journey time data. How did it actually compare to the previous method of control, before you did any of this work? So, that was all there. It had been previously validated using Scoot, a couple of years prior. So they wanted to sort of dig into that. So we had to do a little bit more data analysis, which would make sense. So again, same journey time link, same structure, hopefully makes sense. So the previous method of control, we had the journey times there, and then we had our new optimizer. So how was that compared to Fusion? And again, we were able to start seeing some improvements for our for Fusion running through compared to what was run there before. And this was a conscious choice to put it in seconds. I'll show you in the next slide what that could look like. But this is sort of, I'll be a salesman for a second. As someone driving through that link, they're experiencing a 5 second reduction in journey time through that part of the corridor. And that's kind of what I was trying to balance across the region. I do have some headline figures because everyone always pushes for it, but we were seeing some good improvements across that region. So they wanted that summary of, okay, what does it look like in the AM, PM peak all day, and kind of having that head level number. And we all know in this room, when you're doing before and after studies, percentages can be a little bit of vanity, and then you sometimes get headlines posted on LinkedIn saying, look, we've halved the journey time and all of that. So that will happen, and that's why I sort of just carved it out for a second. But percentages, I take with a pinch of salt. The Fusion improvement is the most important bit for the region, sort of looking at where were we actually able to see how many seconds we were saving across the region. So I'm a little bit over, so just very quickly, it was a real good lesson learned for us, and I think it's important to showcase that these things aren't always straightforward. Launching something new. So we were able to be very methodical when we got some problems. The engineers were happy, the customer was happy, and we were seeing some good performance improvements going through and real good team effort. So that was very much the way we're looking at it. And if you can humor me for 30 seconds more, so I do apologize, stating the obvious slightly, but there is some lessons learned, and it's not too much of a rant, I don't think, but just plan with contingency in mind. It takes time to do data analysis. It will take longer than you expect. There will be detector faults, there'll be a comms issue, there'll be school holidays, because if you're talking about May, June, July, we had to be really conscious to filter out that sort of data so we're not giving anything too biased. Floating vehicle data brings lots of benefits, much easier to gather some data, but it won't work in every single link wherever you deploy it because there just frankly aren't enough connected vehicles giving that information yet. We're getting there, but there's just some caveats for everyone to think about when they're planning it. Really make sure you do have clear processes. That sounds simple, but it's that kind of make sure you're getting your feedback so you are able to learn from it and keep seeing that improvement. And one of the outcomes for us was creating some new visualizations in Fusion as well, being able to really dig in deeper and see, okay, what is it doing? And am I getting the results that I was expecting? And the last thing, I thought maybe people might smile, is when suppliers claim improvements, do ask them to demonstrate how they're testing it. That's a challenge to all of us, I think, to really showcase this. And hopefully you can sort of see the methodical approach that we've taken, and we're able to demonstrate some of the actual benefits that we're bringing to the table. So that was a quick tour. Everyone, I think we're probably just about in time for some Q&A. One question only. A lot of information there. Mark, as always.
Mark Playdale, PTC. Andy, thank you. Really interesting. Floating vehicle, therefore, all that data was traffic related, I take it. Any comments on active travel modes, pedestrians and cyclists, and any impact on those, please?
Yeah, that's a great question. And it's one of the things that we always look at, and cycle time is often used as a proxy for that because the higher the cycle time, the less often the pedestrians will get the crossing. So gathering that data is, again, maybe slightly going back, slightly tongue-in-cheek of, it takes longer, it costs a good chunk of time to do that data analysis. So if you do want to do it, you need to make sure you plan it appropriately to gather the data you want for the active travel. It is a challenge.
Thank you.
But that's where we, as I say, we often use cycle time as a proxy for the active modes. There was another question, but I was maybe told no. Chris has a question. It depends how much you're willing to let him.
How quickly you answer. Take the question, tell me how fast the answer is.
Thank you, Chris Small, Transport for Greater Manchester. A quick question. I say this having only seen demonstrations of Fusion and not used it myself to set up a region. The demonstrations we've been given go on about using these KPIs, key performance indicators, rather than in Scoot using degree of saturation, which we all understand. And I was struggling to get my head around how these KPIs fit in and how you set it up. But then in your demonstration then you suggested there is a target degree of saturation. So is that what it's using then? Because to me that makes sense.
That's probably not a quick answer, but I am happy to at least give a high level and then let's chat about it. So in our cycle time optimizer, we do consider a degree of saturation to sort of get what's the base level of demand needed. So we are serving enough to sort of clear the greens as such. And then when you're sort of reallocating time, that's when you're starting to think about the KPI score. So what is the most important area that needs more time? Where are you giving any spare green, or any decision you're making in terms of like a split, an offset? You're saying, what's the best, thinking about the links that I care about or the routes that you care about, and what modes do I care most about? So it might be that, you know, a bus is considered more valuable than a car, or whatever way you want to do that. So then that's every decision it's making is built up of the KPI calculation, but the cycle time optimizer does consider target degree of saturation just to make sure you're given enough green time to clear it in the first place.
Thank you, that answers the question.
Thank you, Andy.
Cool.